I'm Dr. T. Welcome to my floor. I'm actually going to crack open my computer. It could always use a little bit of dusting. And in the process, I want to point out ways that heat can be moved, because these guys are actually really important for moving heat around. You get a lot of waste heat. Okay, so I'm just going to crack this guy open. Actually, before I do that, let's get this thing a little bit more secured. Probably just being paranoid here. But one, I don't want to lose my screws. And two, what I'm going to do is plug this guy in, but I'm going to turn off the power supply. That way, the power to the computer is not connected, but the ground is. So now the power supply, which is in the back, let me take this guy so you can see it. So hopefully you can see this. The power supply is connected in, it's off, and that way any zaps go all the way straight to the ground. Okay, so I'm going to take this thing apart. I'm going to grab my voltage strap here shortly, once I get this a little bit separated. Okay, and I'm just going to take these fans right off. Okay, so this guy's going to go ahead, come out. I've got my rather dusty fans over here. Actually, I'm just going to go ahead and give these a little bit of a spray. Get a little bit of dust out here. Pro tip, if you're building a computer, one, don't get a case that has the fans on the side. It's an absolute pain. And second, get filters. Dust is not your friend. Okay, so I'm looking inside the computer. I'm going to grab my static strap. This way I will be electrically connected to the case, which is electrically connected to the ground somewhere via my electrical system. And thus, I don't have to worry about zapping anything, which I'm not poking around that much. Okay. That is on. I've heard some folks actually like to put this on their feet. I think I actually kind of get the idea. Okay, so let me grab something pointy. Preferably pointy and plastic. Okay. Huh, that has a hook. Okay, so when we're in here, and let's see if this GoPro is going to let me see what I'm seeing. The joy of photography. Need a mirror. Okay, so I'm going to try and get this in a little bit closer. Okay, so the part that I'm looking at is actually going to be right here. So if I was to take this part off, so you got a great big fan, and then I'm going to try and get this GoPro in a lot closer. So as I'm looking over here, I've got my terrible cable management. But what you see is that you got a bunch of electronics, and what you can't see because the giant aluminum piece is sitting right on top of it is the CPU. This is where all the calculations are doing, well, at least a lot of them. Okay, so I've got that. That's going to be using a lot of power, and due to inefficiency, it's going to generate a lot of heat. So that heat needs to go away, otherwise it gets too hot. And the way I'm going to do that is going to be a couple of things. And it's going to discuss really how heat gets transferred. So first, what you'll notice is there's this gigantic block of aluminum here. And aluminum is a very good conductor. It allows the vibration of the atoms low down on it to kind of jiggle around and move up. And then as they're doing that, they're going to then spread the heat out through the aluminum. This is conduction. It's a classic way of moving heat around. Hey, quick point of clarification while working on this. So I talk about up and down in the video. What I'm referring to is actually where the computer's sitting in the video. So the heat is coming from the CPU. That's where the the electricity is running around, doing the work of rearranging bits, and thus energy is being expelled, as waste heat. Obviously, if your heat source isn't on the bottom, then heat won't be moving from top to bottom. Obviously, if you've got convection that doesn't have a fan or anything, where you're dealing with differential amounts of heat and different densities of air or water, or whatever fluid you have, than up and down matter. But if you're talking about conduction or a radiant, up and down is irrelevant for most things. It's just going through from the hot side. Heat always moves from the hot to the cold. So really, in this case, when I'm talking about bottom, I'm really talking about the hot CPU, which is on the underside of what you're seeing. Now, we got a couple of things that we're going to do to increase this. One, some of the heat will be released by radiation. Those bumping atoms will bump around, but instead of vibrating, they're going to exchange some of their vibrations, and they're going to use that energy to form a photon. And then this photon will be kicked out, and hey, that's able to energize, take that energy and remove it. If I wave my hand over here, and it hasn't been running that long, and the fan's actually pretty good. I haven't been putting on load, but you can feel a little bit of heat coming off of this. And most of that heat you're feeling is radiant heat. So the energy from the vibrating atoms is being turned into a photon. The photon's leaving, it's hitting my hand, and it's causing my atoms to be vibrated. And thus you get this radiant heat. Now, you'll also notice that this block of aluminum, one, there's a big fan over here, but let's see if I can get in any closer. I don't think I can. But if you can see, with my horrible lighting, boy, I wish I had another flashlight. 1 second. Okay, that's not helping much now. Okay, the flashlight wasn't helpful. But let's take a gander at this. So if I'm looking at it, and if I get a good angle, here's a nice angle. So I can see how there's lots of little fins on my heatsink. And what these are for is to allow air to interact with the heatsink, because I want to get this heat out of the computer. Well, the only way I'm going to do that is get that through air. So now air is going to hit the heatsink. The vibrating atoms of the heatsink are going to vibrate the air. But a couple of things are going to go on this one. For starters, I can look at certain parts, and what they can do is simply allow the warmth of the air that's going to cause it to become less dense. The air molecule is going to spread out, it's going to be less dense. Colder air is going to be heavier, it's going to sink, it's going to push them out of the way, and we're going to get what's known as convection. And that will allow me to cool things. However, that one is not quite good enough. So convection is this interesting one. There's a couple of variants on it, because I can modify it, and you can see a couple of the modifications on this computer. First, I got a big old fan right there. That big old fan is going to force air across these fins so that air is able to go across them. And I'm not entirely sure which way this guy is going. I think the air goes down. So it blows the air from the top down across the fins. And as such, now all of a sudden, I'm not relying on just the differential in temperature. I'm able to move air quicker, and this is going to allow me to move heat across fairly quickly because I've got more than just the difference in the density of my air molecules, or pockets of air, I should say. Now, you'll also notice, if you look on most good heat sinks, my cable management's getting in the way, you see those little copper pipes. Those are to help with conduction. Because conduction is kind of a medium grade moving heat around. It's not awesome. So instead, what we want to do is we would actually prefer convection. So those copper pipes run to the bottom of the heatsink, and at the bottom of the heatsink, they're going to be there and they're going to conduct the heat across. Those are hollow and they're filled with a proprietary liquid. The companies don't say what they're filled with, as well as a wick. And so the idea is on the bottom, the liquid boils. As it boils, it of course turns into a gas. It goes up to the top. It condenses, releasing the heat. So these are called heat pipes. They move the heat around quite quickly. Computers definitely a useful way of looking at heat transfer. Because they're doing all of it. Typically, you're not going to do too much radiant heating. Radiant heating is kind of the least powerful, the one that's able to move the least amount of energy over a given amount of time. Conduction, it can do a lot of heat transfer, but it's definitely nowhere near as great as convection, especially once you start modifying the convection with things like phase changes or with things such as a fan or a forced convection. If I had a water-cooled system, obviously I'd have a pump. I'd be doing some water transferring through. That's a variant, once again, of convection. You'll see some of the modified versions get different names, which is because they are meaningfully more capable of moving heat around. So while I clean, have a wonderful day.